Hey, what's up guys? Welcome once again to the channel in which we talk about chemical and process engineering for both students and professionals. In this video, we're going to be making a tier list, which is essentially this type of list that are very popular in the video game scene. I actually have seen some videos on Age of Empires, so if you know it or you have played that, let me know in the comments. I really enjoy that game. It's a strategic, real-time strategy game of the Middle Ages. Really enjoy it. And they usually use this tier list to show the hardest things or the most popular ones, the most economic upgrades or military upgrades and all that. And I thought to myself, why not do this for chemical engineering stuff? And in this case, we're going to be talking about courses that are important or relevant for both your student and professional life. So I'm going to be focusing mostly on actual chemical or process engineering subjects, not that much into chemistry or math or physics, which of course are relevant. You cannot survive engineering without math or not knowing about physics. There's one thing, maybe you can survive not knowing that much chemistry. That's up to debate, to be honest. But for now, I don't want to get into that. Let's go directly into the list. And the list, let me show you guys, is essentially right here. So we have design of experiments, material and energy balances, fluid mechanics, momentum, heat, mass transfer, environmental engineering, process simulation, process design, quality control. There's a lot of subjects that are pretty common to find in the chemical engineering curriculum. One thing I want to say, guys, please check out the equivalent for your university. Unfortunately, there's a lot of fancy naming in this type of education. They will change it so it sounds better or more attractive for students. For instance, mass transfer doesn't say that much. There will be some universities that may prefer to use advanced process separations or simply separation technologies, which sounds more like, as a student, you see separation technologies sounds like filtering or like separating chemicals rather than mass and diffusion, which sounds very abstract. Okay, so if you have a doubt, maybe you have this name that you want to, let's say, translate it to the list, let me know and I will kindly answer you. Now we got a lot of them. I tried to include the most important ones and of course those that may be like common to study as a chemical engineer but might not be relevant in some cases. Some of them are not included. For instance, if you're in biotech or chemical engineering with biotech, I didn't include biotech itself or pharma and all that. Okay, so let's get to the actual list and see the list order. So I don't think this is the reality or let's say the overall or the unique truth. This is just my opinion on what I have been listening or hearing with my friends, colleagues, students that take my courses, professionals that are selecting courses depending on their needs. So this is just a oriented guess, not a random guess, let it be. Okay, now let's get started. I'm going to be selecting the very first and most important one, which is mass balance. I wanted to select this because it is, in fact, one of the very first chemical engineering subjects that you are going to be encountering in your student life. And I really think this is one of the core subjects, not in the sense of the theory behind chemical engineering, but because it's going to be separating a lot of types of students. Number one, it's going to separate all those people that went to chemical engineering thinking it was lab work or chemistry itself. Maybe there are lost chemists that they went because of peer pressure or because they think engineering is great, so they wanted to go to chemistry, but they end up in chemical engineering. They think it's pretty related, which in some cases can be. And well, they just decide in this specific course in mass balance that this is not the case, that mass balance is more about processes, process flow diagrams, streams, energy, heat, cooling down, heating, adding work, agitation, reactors and all that. And they see that it's not a good fit and it's fine. They will end up dropping out or changing to another bachelor. Now the second group, let it be, will be all those chemical engineers that want to actually be chemical engineers, but will have a hard work or a hard time with chemical engineering overall. And mass balance is that exactly. The first encounter with chemical engineering, they will see this is a abstract engineering. Maybe you need to think about more, let it be like difficult scenarios or subjects, processes, the recycle and purge, all that, those things start to get like problematic, especially when you are writing equations. And then we have another group, which is a great group, are all those people that do not have a problem with that and are actually enjoying chemical engineering. They love that. They see the square, the box, the design, the column. They see how it's getting separated. They have a feeling of what's going on. They have this like grasp of, okay, why do we have 3% in this stream if we just separate it from a 2%? Shouldn't it be lower amount? Those people are going to be having a great time. And I say mass balance is very important because from now on, if you have a core fundamental of the understanding of mass balance, you are going to have a great time. If not, you're going to have maybe a harder time than others, but doesn't mean that this is the only way that you will be going through. So talking about energy balance, it's important. So I place it in A tier, which is very important tier or very high tier, because it's the place in which you're going to start relating energy and mass. And there's no energy balance that you can make if you don't have the mass balance. And talking about energies, you're going to get related to heat. I was going to say Q, but no, actually it's heat, energy, either heating or cooling. You're going to get related to work, either or shaft work going in or taking it out. You're going to get related to electricity, which can be converted into work or into heat or so. So it's a cool way to relate all these type of energies. So for me, it's also the introduction to thermodynamics. Talking about, I separated thermo into two subjects because it's very common to have at least one subject which covers most of thermo topics relevant for chemical engineers. But there's also a thermodynamics 2, which is not that common. And then you may end up to have Thermo 3, maybe even Thermo 4. I think those are extra, not so much of a need for thermodynamics, unless, of course, your focus is energy or processes of energetic requirements. Let me place Thermo 1 in the, no, actually I'm going to go S tier. Thermo, in my unique understanding, is this. So thermodynamics is very important because it's where the chemical engineer is going to start not being able to relate to real life, meaning that there will be equations that don't relate that much into real life and that you need to trust that you're doing this great. For instance, entropy, if we're talking about the dissipation of energy, Carnot cycle, if you're using Maxwell equations, the Joule-Thomson coefficient, all these things that are not that quite, let's say, easy to get. For instance, it's not like temperature. You understand that the higher the temperature, the more it's going to be dissipating heat, or so it's going to be quote unquote hot. But Thermo 1 is this subject that is going to be separating all those engineers that can do this abstract modeling and separation, and all those that are going to be having a very hard time and that they cannot understand these abstract concepts in thermodynamics. So that's why I think it's important, and you will end up using it in the life or professional life most likely, because energy is everywhere. Talking about thermo, let's go for Thermo II. Let's be honest, I'm going to place it on B tier because you already know Thermo 1. You know the basics about heat, energy, how it interacts, how do they transform, why you can never convert all type of a single energy to another energy. And in B tier, I think it's relevant because Thermo 2 is most likely going to be related to equilibrium thermodynamics or vapor, liquid, solid interactions, which are useful for mass transfer, which is of course very important. But you can get away if you don't get that much Thermo II, if you don't get the activity coefficients or the fugacity concepts. It will be great if you can do it, like if you dominate it, but if you don't, make no worries, guys. We got your back. Now let's go for something more random. Let's go for quality control. It's an important subject. I'm going to place it on D tier, and that I don't want people that may be working already in quality control. I don't mean that it doesn't care or it's not an important subject. When we talk about quality control, it means that when you get the job, you are going to be most likely trained on the quality control issues, or most likely you can always get a diploma on Lean Sigma or quality control, or maybe you can end up in a master degree that is, let's say, on quality production or quality control. But if you can get away without having any contact, any kind of contact with this subject, and still be considered a great recent graduate. Talking about quality control, like some lean manufacturing, once again, these subjects, I don't mean that they are not important. They are just not so, let's say, important for you to be as a graduate. They will not expect you to know about lean manufacturing, or at least not that much. They will train you if you get a job related to that, or you can always get a diploma. It's pretty straightforward. It's more like a theoretical concept. If you understand the thermodynamics one, the mathematics or the mathematical models that you end up using in lean manufacturing are not that extreme. So make no worries, guys, relax. You will end up doing great. And I have environmental engineering, and I know this is a sensitive topic for many. Should be S tier in the sense that we are destroying the world and we are like in a time ticking bomb. But to be honest, you can be a great engineer without that much of a environmental engineering knowledge. I don't know. I will say B tier, and this is why. So you can end up without any knowledge of environmental engineering, and you will end up in a company, hopefully in a big company, that will not allow you to be doing chaos with environmental stuff. Meaning that there's a lot of legal norms and a lot of internal norms that will not allow you to do huge messes with the environment. And once again, if you really want to get into that, you will most likely end up doing a master degree, at least a master degree. If you have a little knowledge in that, it's great. If you don't, make no worries. It's more important to have other type of courses. Design of experiments, definitely, well, not definitely, actually, I'm having my doubts between B and C. Let it be C. It's very important because if you are working with experimentation, which is very commonly in the process engineering area, but I'm confident that there is not always this application for other types of engineering work. What do I mean with this? Is that if you are actually testing, actually let me go back in time when I was a young process engineer. So there was this problem, which was, let it be the weight of these threads of polymer that we were doing. We had some issues, and there were two main ways to go. The very first one would be go take a lot of tests, change the machine into different temperature, pressure, a lot of conditions that needed to be changed in order to understand how the process worked and try to make a verdict. Or do an actual design of experiment, which I didn't remember that much at the time. I did have that course and I reviewed it. I did my design of experiment, required only about 5 to 7 tests instead of 100 tests that I had previously required. And yeah, if you talk about price or cost, having less testing is always great, because, and more importantly, if you have the statistical core that bases or that backs you up, you can go with your senior process engineer and say, here's the data, here's the statistics. I don't need 100 points. I can do it with 7 points. It's cheaper, it's faster, operationally easier. That will be great. And that's a skill that definitely is important for a chemical or process engineer to have, but I know that this is unique for process engineering. If you're designing stuff, if you are doing sales, that's not likely the case. And that's why I end up putting this on C tier. Let's continue with one of the most important ones, fluid mechanics. I will say it's between S and A tier, but I'm going to place it on A tier because, guys, what I want to do is also a normal distribution. I want to favor a lot of A, B, and C, and very small amounts in S and D tiers. And the thing with fluid mechanics is that it is important. For me, it's fundamental to have engineers that understand how fluids move, why do they change liquid gases, how do they interact in reactors, in pipes, in pumps, compressors, in exchangers. If you don't understand this, because I will say like 80% of chemicals will be treated in liquid or gas state, you are like nowhere. You cannot be selling your services as an engineer if you don't understand this. Talking about fluid mechanics, I have momentum transfer, which are pretty similar. Maybe in your university you can have them united, or let's say a joint subject or course. There are some universities that have several separations. One is for more into the theoretical concepts, and the second one is more into actual application of unit operations. And this is what I want to show you on momentum transfer, guys. Momentum transfer is more about the equipment that you will end up using for those fluid mechanics. So you understand the theory, you understand the mathematical models. Now you have this toolkit of equipment that can be used. So you need to increase pressure. What do? You either use a pump for liquids or you use a compressor for a gas. If you want to have a valve to decrease pressure, you have it there. If you want to expand the gas, you have it there. If you want to have a fluidized bed, you can have it there. So for me, it's very core fundamental. Actually, all unit operations should be of primary concern. Now let's continue talking about unit operations with heat transfer. Once again, very important one. I'm actually between the A and B because it's important in the sense that you will be using it a lot, but it's not that difficult. So I don't know if I should be placing it in A or B, but let it be in A, because someone that doesn't know how heat exchangers work will be definitely a problem. And those are the typical unit operations that you will encounter in any kind of operation. Like even in offices, you have HAC or HVAC, as you call it, air conditioning. Sorry, I'm watching here because I have air conditioning. But yeah, you need to know it and you need to understand it, and you need to know also the difference on if you need to boil something, condense something, and all that. I'm going to place mass transfer in the B tier. I know that maybe you're wondering why I didn't select the A tier if we already have momentum and heat transfers. And this is essentially because I know that mass transfer is important. Separation processes are core part of chemical engineering, but I think you can get away with not knowing that much into how it works. And to be honest, nowadays we have a lot of equipment which you understand the mass transfer idea, but the operation is quite different, and they will end up training you a lot into that thing if you're actually into that. To be honest, there's a lot of process engineers that will not work with actual mass transfer equipment, such as distillation columns. They will not use any absorber or so. They will go mostly into process engineering stuff like movement of fluids or filtering, more not so technical or tactical strategically for the industry. Although there's a lot of process engineers that go directly and work with reactors and work with crackers and all that. So I don't want to offend you guys. Doesn't mean that recent graduates don't end up doing this. It's just that I would prefer to have someone that dominates heat and momentum transfer over that guy that has the mass transfer. Because to be honest, mass transfer has momentum and heat transfer itself. If you have a distillation column, try to imagine the distillation column, you have a valve, you have a heater or cooler that sets up the temperature and pressures, you have the condensers, either partial or total. You have the reboilers. You need to know about vapor-liquid equilibrium and all that. So quite a challenge right there. Transport phenomena, straight to C tier. It's important because it's the basis or the theoretical basis of all transfers, understanding mass transfer, momentum transfer, understanding the heat transfer as well. All the laws, Fourier's law, Fick's law, Newton's law are important, but you can get away with motor. I know a lot of chemical engineers that do not actually know how to model the typically falling film or the typically slopey. It's fine because you understand the concept, you already work it once or twice, and then you use those concepts to actual things that work. For instance, if you're talking about heat exchanger, you have the coefficient. You understand that the coefficient either will be given by the manufacturer or the company has certain guidelines, or you will end up calculating it with some computer or computational tools. So no problem right there. Reactor engineering, and I usually, when I talk about unit operations, I usually like to include chemical reaction engineering or reactor engineering, whatever you want to call it, because it's also another unit operation. And one of my professors always told me that the thing that separates mechanical engineers from chemical engineers is the reactor, that we know about reactions, we know how to work with moles and all that. If you get back, momentum transfer is about pumps, compressors. Anyone on mechanical stuff can do that, so it's not unique to the chemical engineer. The heat exchanger as well, using plate exchangers, using coil exchangers, using shell and tube exchangers, condensers, reboilers, kettle reboiler, all that. But the core one is the reactor engineering. For me, reactor engineering is the magic that happens, that transforms the materials, that the pure definition of a chemical engineer that converts a low value material into a high value material. So talking about that, I will add it on the B tier because it's core fundamental. But to be honest, guys, there's a lot of processes that do not include any kind of chemical reaction. So you can get away with that. Once again, it's not likely that you end up working with a reactor if you go straight from graduate. And if you do, they will most likely train you. Or it will be pretty straightforward. The control, mostly control or automatically control. Reaction kinetics, well, we talked about reactor engineering being important. Definitely it's a C tier, not so low as quality control in manufacturing, which is, once again, some other area of industrial engineering. Reaction kinetics is actually chemical engineering overall, but you can get away, once again. You can have a chemist that helps you with that, or simply you will be trained to understand the specific kinetics of the given process. You don't need to know about all the kinetics. You just know about the optimization of your unit operation. Let's continue with process simulation, which is one tool that if you already know me from my channel, you know that I love process simulation. There's a lot of mini lectures, free courses, paid courses in my website if you want to check them out. But process simulation is a unique thing in the sense that, to me, all the future of chemical engineering is going to be decided by who has the best decisions made from artificial intelligence, big data, analyzing processes on very, very large scale, asset control, asset management, and of course, process simulation. So it's important because it's the future. But to be honest, the probability of you ending up working as a process designer with process simulation is very low. Now it's time to talk about unit operation labs. It can be one lab. In my personal experience they were two labs. So one was heat and momentum, and the other one was mostly into overall process and reaction engineering and a little bit on mass transfers. I'm going to set it up. I'm between A and B. A, because if you have engineers that only have theoretical concepts, it's very hard to imagine going to the industry and understanding that this huge equipment is a chemical reactor and this is a heater. It's very hard. But if you had the chance to go and work in the lab, a chemical engineering lab, it's very gratifying and it's great that there are a lot of engineers still working with that. So in my opinion, still important. If you are those students that may end up not working in a unit operation lab, that's fine. That's why I am placing it on the B tier. It's fine. You don't need to have that practical experience. If you have the theoretical experience or the theoretical idea, of course. Control and automation. To be honest, I was going to place this on the C tier, but so far I have interviewed in my podcast some guests that say that control and automation are like the top of the line things they will recommend their peer or recent graduates to go for. So I'm going in order to honor them, I'm going to be adding them in the B tier, meaning that if you know how to control and operate the process, you are doing great. To be honest, I was not that great on that. I had problems on the experimental part as well. I remember being there and I was really mad at me because I understand all the theory behind the process, but I had a lot of time or hard time understanding the automation part or the control, all the loops, how to interact, PID, all that. Had a very hard time. But as my friends on the podcast told me, it's important, so that's why not C tier, I'm going for the B tier. Process analysis and design, I'm between A and B tier. A tier because the main goal of a chemical engineer is to be able to design, operate, analyze, optimize, and work with a process, chemical process. So either you're going to start a new company, they will need a new process. Either you need to make a larger or revamp a chemical plant, you need to know how to do it. There is malfunctioning, you need to know how to troubleshoot. There's people in consulting paying you to optimize the process, you need to know how to optimize. So this is A tier, but don't get that extreme into the sense that it may, I'm going to get roasted because a lot of people are going to say, why not S tier? I think that you can get away with not knowing that much into actual process, overall process design. If you understand the unit operations itself, that will be good enough, in my opinion. I don't know, guys, what do you think? I would love to see your comments roasting me. This should be on S tier. And final project, I didn't know how to name this. This is the typical project. It may be a thesis type project or a small internship co-op. I will really recommend to have a final project. But to be honest, if you don't have it, or if you fail it, or you didn't get a, no, not C tier, actually, I'm going to place it on B tier because this is not only about you going and making a project for your class. It's also important for you to have in your CV and be able to show to your recruiter, to the scouts, that you are actually working with chemical engineering things. So for instance, if you work in a design of a small plant, if you work in a refinery, would be great. If you design a process without even going to a chemical plant, it was all you or maybe your team working on that. If you optimize certain process, that would be also great to show. So that's why I'm going to be using the final project in B tier because it's important and relevant for your professional life. Even though I'm trying to remember one of my experiences, I did have a final project and it was on this company, which is a Cemex. It's named Cemex. It's a Mexican cement company and it's very large, and it was great to know that I had contact with those people that may end up vouching for me or even giving a offer. I didn't try to search for that because I'm not into cement industry, but it was great to know that final projects work for that. They will have this like disclosure of your understanding of all the subjects, how to be able to design processes, optimize them, on all that, and also will help you with your professional life. And this is how it ended up. So S tier, mass balance, and Thermo I, which I think are the most important ones. Then A tier, energy balance, fluid mechanics, momentum, heat transfers, process analysis and design. Then we got B tier, which is of course an important fundamental, Thermo II, environmental engineering, mass transfer, reactor engineering, control automation, unit operation lab, final project. Then least important, yet relevant, design of experiments, transport phenomena, reaction kinetics, process simulation. And the least important, quality control and lean manufacturing. And that was it, guys. So let me know in the comments if you have any doubt, comment, especially if you think one thing should be changed or if I missed something. If you haven't subscribed, please hit the subscribe button. You will be getting a lot of videos out there of myself. I'm now committed to get more video content like this, more like entertaining but still educational videos. And of course, hit the like button if you like it. It really supports the channel because it starts showing to other fellow chemical engineers that might need this, and I really will appreciate if you do that. So guys, that was it. Take care. Bye bye.